Hey Annabelle, thanks so much for your questions. I've just combined the two of them together here because I think it's pretty much the same concept for both. So I'll just demonstrate like the use of number lines um, for all of them pretty much. But yeah, um, I should note by the way that this isn't um, part of the syllabus that I went through. So if I'm doing them a bit differently to how you've been taught, um, apologies for that. But hopefully we're on the same page in terms of solution. Look, one here and one here are essentially the same problem. So I'm just going to work one and I'll show you it on a number line. Okay, so what we've got is 1 on x has to be greater than 4. And the starting kind of thing you want to do here is get it all over to one side. So instead of having a 4 here, I'd like to have a 0. And so I can take 4 from both sides, and that will give me 1 on x minus 4 is greater than 0. Cool. Now, here's something important that you need to remember, is that you want to be able to evaluate like x values that are going to break the function, right? But at what stage you need to do that is when you've actually got a common denominator. So this negative 4, we actually want to make that sit within the fraction itself. And so to do that, we need to multiply by x on top and bottom. Right-hand side stays the same. And now we can say, okay, therefore, 1 minus 4x over x is greater than 0. Now the next step here, once we've got this equation and we've got it in relation to 0, our next step is to try and find critical numbers. Critical numbers being where either the function breaks or it switches from being a positive or a negative solution. Meaning, when does 1 minus 4x equal 0? And when does x equal 0? Obviously, the two numbers here are going to be x equals 0, one of them, and also x equals 1 on 4, I believe. Yeah. All right, so I've just constructed a number line here, and I want to partition it off into kind of 3 segments. So I've got a segment where x is less than 0, the segment where it's between 0 and a quarter, and the segment where it's above a quarter. What we need to figure out is, okay, for our x values, all the possible x values, when is the solution greater than 0? What we can do here to figure this out is substitute in specific values, either side of our number line partitions. And so the 3 numbers I'm going to pick here are x equals negative 1, just going to be red. For this sector, x equals 1 on 8 for the middle sector, and then x equals 1 for the sector on the right. Okay, and if we start with x equals 1, if we sub that in, we get 1 minus negative 4 times 1 over 1. That will give us 1 minus 4 over 1 is negative 3. Sorry, I start that one up. This we just tested x equals 1, but x equals negative 1. Sorry, so x equals 1 is false for the solution. If we put in x equals negative 1 now, sorry, negative 4 times negative 1 over negative 1, you're going to get a positive solution at the top. It'll be 1 plus 4, which is 5, but it'll still be negative 5. So actually, this is also false region. And then that's going to mean that this middle region is true. Let's still test it though. So it's 1 minus 4 times 1 on 8. And all that divided by 1 on 8. So that will give us 1 minus 1 on 2. That's then all multiplied by 8 on 1, because we had multiplied by the reciprocal. So that is a half times 8, which will give us 4. So it's positive. And because values in this region give us a positive solution, they're consistent with the equation here. So our solution set for x is going to be x is greater than 0, but not equal to, because when x is 0, that's our critical point, but the actual function is 0. And x is less than a quarter. So that would be our solution set there. And actually, I've probably drawn that wrong. It would be the other way around. Like, as in 0 goes here, is less than x, and x is less than a quarter. So that's how I do that first question. All right, I'll pick one from the other side now, and we can do question 7. So that's 1 over x minus 1 being greater than 4. Okay, so step 1 again, we want to get a 0 here. So we're going to subtract 4 from both sides. That gets us our 0. Now we want a common denominator. So we multiply top and bottom by x minus 1. We can combine it now. So that's 1 minus 4 x minus 1 x minus 1. And there's a bit of simplification we can do here, because if we multiply that through, that will become 1 minus 4x plus 1 more. And so, And so what we can do there is say, okay, well, that's then just 2 minus 4x. And do we agree that if we've got 2 minus 4x, we can say that that equals 2 outside of 1 minus 2x. So that's how I'm going to write the top. Is 2 outside of 1 minus 2x. Cool. And then the bottom stays the same. It's still x minus 1. It's greater than 0. Okay. So now we've got to find our critical points. And they are, again, going to be when the denominator or the numerator is 0. And on the top, we would have to have 1 minus 2x equals 0, which means that x equals a half. And then on the bottom, x would have to equal 1. So when we go to construct our number line here, we're going to have the region between a half and 1 kind of be our dividing line. So I'll set that up. Okay, so there are our 3 segments. And let's start with looking at x equals 0 for this side. We can look at x equals maybe 3/4 for the middle quadrant. And then for this side, let's look at x equals 2. Okay, so we'll start on the far left, and that's with x equals 0. If we sub in x equals 0 here, we'll get 2 outside of 1 minus 0 over 0 minus 1, which is 2 times 1 over negative 1, which is negative 2. We're looking for positive solutions. So that means that this side is out, not part of the solution set. If we jump over to the other side then, if we sub in 2, we've got 2 outside of 1 minus 2 times 2. And x minus 2, 2 minus 1 on the bottom. That's going to equal 2 times 1 minus 4 over 1, which is going to be 2 times negative 3, which is negative 6. Again, it's a negative, not part of the solution set. So like we saw in the previous question, the true answer will sit inside our quadrant in the middle here. And so we can write our answer as x has to be greater than a half, again, not equal to, and less than 1. Okay, and to test our knowledge with some more difficult ones, I want to have a look at both 18 and 19 quickly. So to start 18, I've just moved 3/4 to the other side. And now we've got to get these to a common denominator, which is a bit more labor intensive, because we've got to get 4's over here and then 5x plus 1's over on this right hand bit. So we can multiply that by 4 and all of this by 4. And then we can also do, well, 5x plus 1 and then 4 outside of 5x plus 1 there. Still less than or equal to 0. Is that all good? Yep. So then we've got a common denominator and we can put it together. So that is going to be 4, so x minus 2 minus 3 outside of 5x plus 1 all over 4 outside of 5x plus 1, and that's less than or equal to 0. Okay, so now we can do some expansion along the top. We can say that's 4x minus 8 minus 15x minus 3. And that's still 4. So x plus 1. Still 0. Okay. Now we've got some terms that we can work with. That's going to be negative 9. No, negative 11, sorry. Negative 11x minus 11, conveniently enough. And then on the bottom, we're going to keep that. And then here we can take out a factor of 11, or negative 11 even, to just get x plus 1, 5x plus 1, less than or equal to 0. Alrighty, so from this then, our critical points are going to be at x equals negative 1 and at x equals negative 1 on 5. So that's how we're going to construct our number line. Okay, so there's our partition again. The 3 we're going to test, let's say negative 2, let's say 0, and let's say x equals negative a half. Let's do those 3. So if we start with x equals negative 2, we're going to get negative 11 outside of negative 2 plus 1 over 4 outside of 5 times negative 2 plus 1. It's, yeah, we're just evaluating that. So that'll be negative 11 times negative 1 over 4 outside of, that's negative 10 plus 1, so negative 9. And so that'll be a positive on the top, but a negative on the bottom. And so this will be a negative solution. Okay, so let's move on to negative a half now. So we'll go negative 11 outside of negative a half plus 1 over 4 times 5 over 2 plus 1. And that's going to equal 11 times 1/2 over 4 times, that's going to be 7 on 2. So we're going to get a negative on the top and then a positive on the bottom. So it's going to be a negative solution overall. Likewise, when we go 0, let's try 0, we're going to get negative 11, 0 plus 1 over 4 outside of 0 plus 1. That will be negative 11 on the top again, and then 4 on the bottom. So once again, that's also going to be a negative solution. Okay, sorry. So I just realized I made a mistake here because, yeah, you wouldn't expect all three to be negative. So I guess this is a good bit of troubleshooting on the fly. If you see all three of the same sign, it's a bit weird. And so what the mistake is, I forgot to put this part as a negative. So that's 5 times x. It should be, oops. It should be 5 times negative 1 on 2, which changes things because then instead of this being 7 on 2, it's actually negative 5 on 2 plus 1, which is 2 on 2. So we're going to get negative 3 on 2, which means we've got a negative on the bottom, a negative on the top. So this one is actually going to be positive. And that makes a lot more sense here. So what this tells us is the positive solution we are going to ignore. 2 negative ones we're going to keep. So it's good in this segment and this segment. What's interesting though here is that 0 is actually allowed within our domain. So when we represent our solution set, we can include our critical points. And so we can say, look, this is, or sorry, no, not quite. We can include one of them. We can include x equals negative 1. And why that is because x equals negative 1 just makes it 0. But if we put in x equals negative 1 on 5, that actually makes this bottom bit 0, and is therefore undefined. And what this means is that x will be less than negative 1, less than or equal to negative 1, but it must be greater than negative 1/5. Like that. It has to be less than or equal to negative 1 and greater than negative 1/5. Or probably the preferred way of writing this is that negative 1 is greater than or equal to x, and then x is also less than, greater than negative 1/5. All right, let's have a look then at 19. And this one is a little bit different just because of that squared term. So we've got x squared is 5 over x, and that is less than 4. Or less than negative 4. Less than negative 4. So when we start, we're going to move 4 over. That's going to give us x squared minus 5 on x plus 4 is less than 0. Again, common denominator. So x squared minus 5 on x plus 4x on x less than 0. Let's combine that. So x squared minus 5 plus 4x over x less than 0. We've actually got a quadratic here. So we need two numbers that will multiply to give us negative 5 and add to give us positive 4. That's going to be negative 1 and positive 5. So then our critical points will be at x equals 1, x equals -5, and then it'd break at x equals 0. So we've got kind of three actually distinct divisions here in our number line. So I'll go and draw that, and then we can figure out our solution set. Okay, so here's our number line, and now we're going to choose some values. So we'll go -6, we'll go -1, we'll go 2, and then in between here we'll go 0.5. So there's one extra than usual. All right, let's start with -6. So if we substitute -6 in, we're going to get -6 minus 1 times -6 plus 5 over -6. That's going to be -7 times -1 over -6. So can we see that that's going to be a negative over a negative? So this will be a positive solution. Cool. All right, let's start with -6. So if we evaluate at the top here, that's -7 times -1 over -6. From this, we've got a positive on the top and a negative on the bottom. So that's going to be a negative overall. When we look at -1, it's going to be -1 minus 1 times -1 plus 5 over -1. That equals -2 times 4 over -1. We've got a negative on the top, a negative on the bottom. That will be a positive solution. If we skip over to 0.5, so we can say that's 0.5 minus 1 times 0.5 plus 5 over 0.5. And that's going to be a negative 0.5 times 5.5 over 0.5. So again, negative on the top, positive on the bottom. We're going to get a negative result. And then I'm sure, based on the pattern you've observed so far, you can predict the next one's going to be positive, that they're going to alternate. But we can check it still. So what was our number? It was 2. So let's do that. So 2 minus 1 times 2 plus 5 over 2. That's 1 times 7 over 2, so definitely positive. Okay, and back to our domain now. We were looking in our solution set for all the negative ones. So that's going to be this one and this one, meaning that the segments that are negative are here and also here. How I represent this is a little bit different because we've got kind of two very distinct segments. And it's also not inclusive. There's no greater than or equals to here. So this one's easy enough. So we can say that x has to be greater than 0, less than 1. Or x can actually also just be less than -5. And those are our two solutions. Awesome. So I hope that gives you a pretty decent overview of how to solve some rational inequalities. I definitely haven't, that's not exhaustive. I haven't covered everything. But hopefully there's enough skills there and tools that you can apply it across the board. Also, it's very possible that I made a couple of mistakes. So just let me know in the comments if that's the case. And I'll be sure to note that. But yeah, I really appreciate the question. I hope that helped you. And we'd really appreciate it if you could support the channel if you found it to be a useful resource. Feel free to ask anything else whenever you want. Thanks so much, Annabelle.